All right, so this video will just go over the slides for today since I'm not here. So if we are trying to make a reindeer pine cone, we would use 4 pipe cleaners, 1 pine cone, 2 eyes, and 1 nose puff. So how many can we make with the following supplies? And if you're watching this, just pause the video for a second so that you can think this through. Okay, so it takes 4 pipe cleaners, 1 pine cone, 2 eyes, and 1 nose puff to create 1 reindeer pine cone. We have 40 pipe cleaners, unlimited pine cones, 25 eyes, and 50 nose puffs. With these materials, we can make 10 reindeer pine cones. What limits the number of reindeer pine cones we can make? The pipe cleaners, right? We only have 40 pipe cleaners, so that means that we can only make 10 of these reindeer pine cones. And then what ingredients do we have excess of? We have excess pine cones, we have 5 excess eyes, and we have 40 excess nose puffs. So just a quick reminder of kind of how we're trying to think about these different concepts. Okay, so yesterday, you all looked at this reaction where we had 5 different flasks with 2 different molar ratios, and we observed how much hydrogen gas was produced in each of these reactions. So 5 reactions which followed 2 molar ratios. So we had a 1-to-1 molar ratio here. And all that means is that we have the exact same number of moles of each of our reactants or starting materials. We also had a 1-to-2 ratio with flasks 2 and 4, which means that for every 1 mole of magnesium, we had 2 moles of hydrochloric acid. So that for this specific example, that looks like 0.15 to 0.3 and 0.3 to 0.6. Okay, so we have our 1-to-1 flasks, flask 1, flask 3, and flask 5, and then our 1-to-2 flasks, which was flask 2 and flask 4. These were the flasks where we ended up having extra magnesium. So we did not have enough hydrochloric acid within flasks 1, 3, and 5 to react all of the magnesium that was in the balloon. And then these flasks, flasks 2 and flask 4, had no excess magnesium at the end of the reaction. So if we're going to look at the microscopic versions of this exact same experiment, this is where we have to think about the actual simulation that you all used within lesson 5, okay? So the simulation allowed us to see what was really happening in this reaction on a microscopic level. When we program the simulation to react the same amount in moles, we see the same patterns that we saw in the video. Okay, so you'll notice here, when we have a 1-to-1 ratio, we have excess magnesium. When we have a 1-to-2 ratio, we have no excess magnesium. So the excess magnesium is shown here as gray circles. Again, the 1-to-1 ratio has excess magnesium. The 1-to-2 ratio has no excess magnesium. Why? That's what we're going to be investigating today. So as we're starting to get into today's class, we need to think about how can we anticipate the appropriate molar ratios before we run a reaction to ensure that we have no excess reactants. Okay, so like for example, here if we had 1 piece of bread and 1 slice of cheese, would that equal 1 sandwich? No. If we actually count out how much ingredients we have within the ingredient side and then within the sandwich side, we would get these numbers. So for the ingredient side, we have 1 piece of bread and 1 piece of cheese. For the bread side, we have 2 pieces of bread and 2 cheese. So if we cross off this 1 here and make that a 2, add an extra slice of bread and update this ingredient list here, does that work? Yeah, that works. The same situation applies when it comes to chemical reactions. So here we have hydrogen gas, which is H2, plus chloride, which is Cl2, yields hydrochloric acid, which is HCl. But does this work numbers-wise? No, it doesn't. It's the same deal with the sandwiches. We have too many items on one side of this equation. So if we count, in the reactant side, we have 2 of each of these. We have 2 hydrogens and we have 2 chlorines. On the product side, we have 1 of each. So if we put a 2 here in front of hydrochloric acid, we would then end up with 2 hydrogens and 2 chlorines on our product side. That works, right? Now we have the same number of atoms of each element on each side. So for the rest of class today, you are going to finish Lesson 6, Introduction to Balancing Equations. So it's going to be my expectation that you have this lesson finished coming into class on Thursday. Friday is going to be our quiz that's going to cover Lesson 5, 6, and 7. So we need to make sure that we're getting through Lesson 6 today. So pages 1 through 3 is quite a bit of reading. You're just going to read through how you are going to actually balance these equations. Pages 4 through 6 is where you are actually practicing doing the balancing, okay? And then on Thursday, things are going to get a little bit more complicated with this, okay? It is my expectation, again, that we are finishing this lesson today. If you are having problems with this, I need you to come to office hours tomorrow so that you can get help for this, all right? Because we need to come into class on Thursday with this lesson finished, okay? Thanks.